All right, let's dive into this DeepSeek V3 thing today. This new large language model. It's really making some noise, and we're going to try and break down why. We've got the research paper, a bit of analysis, even some early user feedback. What's got me really interested is how they managed to train this massive model so efficiently. I mean, we're talking millions of dollars saved. It's crazy.
Yeah, no, it really is a feat of engineering for sure. So DeepSeek V3, it uses this mixture of experts architecture, and that's actually key to its efficiency. So imagine, right, like you have this whole team of specialists, and for any given task, you only call on, the experts whose skills are actually relevant. It's basically what they're doing here with the 671 billion parameters. Only about 37 billion are actually active at any one time, and that streamlines the process so much.
So it's kind of like instead of this massive model, going full throttle all the time, it's more like it's delegating, bringing in just like the A team when needed.
Yeah, exactly.
That's pretty cool. So how did they actually pull this off? Like, how did they achieve this level of training efficiency? I know the paper mentioned something about an auxiliary loss-free load balancing strategy. What is that all about?
Yeah. So think of it this way. You've got all these processors, right, working together during training, and it's like this well-oiled machine. And traditionally, you would use these, these auxiliary losses to try and keep the workload distributed evenly, kind of like a manager making sure everyone is, pulling their weight and all. But get this, those extra losses, they can cause inefficiencies and impact the model's accuracy. So DeepSeek V3, they just got rid of those extra losses entirely. They found a way to balance the workload without having to sacrifice any of that performance.
So they're basically like, we trust our system, we trust it to distribute work effectively without all those extra checks and balances.
Yeah, pretty much.
That's a bold move.
It is, and it seems to be working out for them. They also made some really smart choices with the data format, the format they use for calculations. So instead of that usual BF16 format, they went with FP8, which uses a lower precision. This speeds up training significantly.
Mm. Isn't there like a risk though that you lose some accuracy when you switch to a lower precision format?
Well, yeah, there's always, a trade-off. It's like using a map that's a bit blurry, right? You miss out on some
Yeah.
finer details, but you can still, navigate okay. In this case, they just found that the speed gains from using FP8, they were worth it. It outweighed the minimal impact on accuracy. Plus, they still used FP16, but strategically for specific operations where that precision was, absolutely critical.
It's all about striking that balance, I guess.
Right.
Getting the most out of what you have. And they didn't stop there, right? Didn't they also optimize the way data moves between processors during training?
Exactly. They designed these special communication kernels to basically streamline that flow of information. You can think of it like optimizing like traffic routes in a city, right? Yeah. Prevent those bottlenecks and keep things running smoothly.
So they have this efficient architecture, they're using a lower precision data format, and on top of that, they've optimized communication between processors. I mean, it's no wonder they managed to train this massive model on 14.8 trillion tokens in under 2 months. That's incredible.
Yeah, it's really a testament to their smart engineering for sure. They managed to achieve all this efficiency without, compromising performance. And this cost effectiveness, it's potentially, a real game changer. It could make this kind of technology, this advanced technology, accessible to, a much wider range of researchers and developers.
Okay, let's talk about another cool feature that they highlight, this multi-token prediction. They call it MTP. So instead of predicting just one word at a time, like I guess most language models, DeepSeek V3 tries to like anticipate multiple tokens like in advance. Why is that helpful? Wouldn't that lead to more errors?
It does seem kind of counterintuitive,
Yeah.
but predicting multiple tokens at once actually seems to improve how well the model understands the language. Like, think about it. When you're reading a sentence, you don't just process each word like individually,
Yeah.
right? You anticipate what's coming next, based on the context.
So it's like the model is developing a more, I guess, sophisticated understanding of how language flows and how ideas are connected.
Yeah, exactly.
What's pretty cool.
And this look-ahead ability, it could also lead to faster text generation,
Yeah.
potentially. So imagine if you could write a sentence by just like thinking, a few words ahead instead of just typing one letter at a time.
Wow.
That's kind of the potential here.
So it's almost like the model is starting to think more like us humans do. Like anticipating planning responses, not just reacting to each word one by one.
Yeah, that's a great way to put it. They're still exploring the full, potential of MTP, but the early results are really promising. It could have a big impact on both the accuracy and speed of these language models.
Yeah, okay. Now let's talk about DeepSeek R1. The paper mentions they used knowledge distillation to transfer some of R1's capabilities over to DeepSeek V3. Can you unpack that a bit?
Yeah, sure. So it's a really fascinating process, actually. DeepSeek R1 is another language model, but it's specifically designed for reasoning tasks. It's kind of like the logic whiz,
Yeah.
And the researchers, well, they figured out a way to take the essence of R1's reasoning skills and basically infuse them into DeepSeek V3.
So instead of starting from scratch with V3, they gave it like a head start by incorporating some of, the expertise of R1.
Right.
How do you even do that? How do you transfer those skills? What does that actually look like?
Well, think of it like, you're teaching someone to cook. You're having them, watch a master chef. You're not just giving them the recipe. You're showing them the techniques, the little nuances, the intuition that comes with experience. In this case, they used, a combination of data and special training techniques to basically distill that reasoning essence from R1 into V3.
So are they literally feeding R1's output into V3 during training, or is it more about replicating the way that R1 actually processes information?
Well, it's kind of both. They use this technique called teacher-student training, where R1 is the teacher, guiding V3, the student, as it learns. And then they also fine-tuned V3 on these data sets that were designed specifically to test reasoning skills. It's like, putting the student through this intense training program that the master chef designed.
And did this actually work? Did V3 actually become a better reasoner because of this?
It did. And it really, I think, highlights the potential of this whole knowledge distillation thing in AI development. It's not just about building, bigger and bigger models. It's also about finding ways to take the strengths of, existing models and leverage them to create even more powerful and efficient systems.
It's like taking the best parts of different brains and combining them to create this super brain. It's amazing.
Right.
Okay, so let's take a look at how DeepSeek V3 actually performs. I know they tested it on a bunch of different benchmarks, right?
Yeah, they really put it through its paces. They threw everything at it to really see what it could do. And the results, well, they were pretty impressive, I'd say.
So what were the highlights? What really stood out in these benchmarks?
Well, first off, it's clear that DeepSeek V3 is a real contender in the open source world. I mean, it consistently outperformed other open source models, often by quite a lot, actually. And they actually, limited the output length to 8,000 tokens for these tests, just to make sure it was a fair comparison.
Oh, okay. And how did it stack up against those closed source giants, like GPT-4, Claude, those big names?
It did really well on a lot of the benchmarks. It actually performed, comparably to or even better than models like Claude and GPT-4.
Wow.
And especially when you think about the massive difference in resources and funding. It's a huge accomplishment for sure.
That is really impressive. Were there any areas where DeepSeek V3 really, really just blew the competition out of the water?
Yeah, it's really strong on those long context understanding benchmarks like drop long bench V2 and frames. Remember those massive 128,000 token contexts we talked about?
Yeah.
Well, these benchmarks really test the model's ability to really process and understand huge amounts of information.
Right, right. So it's not just about remembering a bunch of text. It's about actually making sense of it. It's finding the needle in the haystack.
Exactly. And on frames, which is all about answering questions based on these 100,000 token contexts, it actually came a close second to GPT-4.
Wow.
It beat all the other models.
That's amazing.
Yeah, it really shows that DeepSeek V3 can handle these really complex, information-rich scenarios.
Yeah, yeah. That's a testament to, all those long context training techniques.
Right.
So what about code and math? How did it do on those? I know that was a key focus for them during training, right?
Yeah, they tested it on both engineering-focused tasks and algorithm-focused tasks. On the engineering side, it did trail behind Claude.
Oh, okay.
But
Yeah.
still, it significantly outperformed, all the other open source models.
So not quite at the top, but still, a strong contender.
Yeah, exactly.
Yeah.
But on the algorithm side, it was a clear winner. It beat all the baselines on benchmarks like, Human Evil Mole and Live Code Bench.
It's like a coding superstar. especially it seems when it comes to algorithms.
Yeah, that's right.
Yeah.
And I bet that, knowledge distillation from DeepSeek R1, that really helped out there.
Yeah, probably. All that targeted training, it looks like it really gave it an edge. This kind of performance in coding, though, that could have a really big impact on the open source community, right? Like
Mm.
making these advanced capabilities freely available. It could really speed up innovation in fields like, I don't know, software engineering, algorithm development, that kind of stuff.
Yeah, you're right. It's democratizing access to, cutting edge AI, which is really exciting.
Yeah, yeah. Okay, so let's not forget about its Chinese language capabilities. The team, they were very clear that that was like a priority for them.
Yeah, and it really shows on the Chinese Simple QA benchmark, it completely crushed the competition.
Yeah.
It beat Quinn 2.572B, which is a really strong model, by over 16 points,
Whoa.
even though Quinn were actually trained on a larger data set.
That is a serious victory. And it did pretty much the same as Kin on CEVAL too, right? Which is supposed to be like a really tough benchmark, especially for like Chinese educational knowledge. Clearly, this model can handle both, English and Chinese like a champ.
Yeah. It's really remarkable.
Yeah.
And, the research, they actually emphasized the importance of this whole cross-lingual understanding thing. They said, models like DeepSeek-V3 could have a really big role in breaking down those language barriers and, helping people communicate globally.
It's not just about like, building a better language model. It's about building a more connected world.
Right.
I love that.
Yeah.
Okay, but so far, all these benchmarks are like very specific tasks. What happens when you just kind of let DeepSeek V3 loose, like on more open-ended conversations where it can really show off what it can do creatively?
Well, for that, they use what they call LLM judges.
Hmm.
So these are benchmarks like, AlpaCai 2.0 and Arena Hard. So basically, GPT-4 is used to judge the quality of the responses in these pairwise comparisons.
Oh, interesting. Okay.
And let me tell you, DeepSeek V3, it really shone.
So it's not just a number crunching code rating machine. It can also hold a conversation, have a chat.
Oh, absolutely. On Arena Hard, it actually achieved a win rate of over 86% against, the baseline GPT-4 model,
Ah,
which puts it, right up there with those top-tier models like Claude.
that's incredible. So this is showing that open source AI can really truly compete with like the best of the best, right?
Exactly. And on AlpaCai 2.0, which is more focused on, following instructions and general conversation, it actually outperformed both closed source and open source models. So it's
Yeah.
showing off its, writing skills and its ability to kind of have these natural sounding dialogues.
Okay, so we've got a strong writer, a sharp reasoner, and now it turns out it's also a smooth talker.
Yeah.
What can't this model do?
Well, there's one more thing we haven't even talked about yet. It turns out DeepSeek V3 is actually pretty good at judging its own work.
Wait, what? Like an AI critic. I thought we humans were still in charge of all that subjective stuff.
I know, right? It sounds crazy, but they actually found that using DeepSeek V3 as its own reward model during
Yeah.
training actually improved its performance.
So wait, it's learning to evaluate its own responses and then adjust based on that.
Yeah.
That means it's getting feedback not from humans, but from another AI. Is that even reliable?
Yeah, that was my first thought too. But the researchers, they actually compared DeepSeek V3's judgment abilities to those of GPT-4 and Claude on a benchmark called Reward Bench. Well,
I bet it did amazing.
you're right. It performed just as well, if not better, than those models. And this whole, self-evaluation ability, it could be like a real game changer for AI development. Imagine AI systems that can just figure out their own weaknesses, target those areas for improvement, and basically, bootstrap their own learning.
Okay, now that's where things get really interesting. And maybe a little scary too. Like if AI can actually judge its own work, could it potentially even guide its own training process? I mean, where does the human oversight come in?
Yeah, that is a crucial question, and it's one that researchers are, really thinking about a lot right now. It's kind of like, giving a student the answer key to the test and saying, okay, figure out how to get a perfect score. It could lead to incredibly rapid progress, but it also raises these, concerns about control, alignment, all that.
Right, right. We want to make sure AI is working with us, not becoming its own independent thing with its own agenda.
Exactly. And that's why all this research into AI alignment and safety is so important. As these systems become more autonomous and self-directed, we need to make sure they're still aligned with with human goals and values. It's a really interesting glimpse into the future of AI. Maybe a little unsettling, but definitely interesting.
It really is like we're opening Pandora's box, but instead of unleashing like chaos, we're unleashing potential, you know?
Yeah.
But with that potential comes a lot of responsibility.
Yeah, you
Huh.
said it. And speaking of unleashing potential, remember how we talked about that multi-token prediction thing,
Mm.
that MTP,
Yeah.
and how it could speed up like text generation? Well, they actually tested that too.
Oh, really? Okay, so they didn't just like, theorize about it. They actually measured how much of an impact it had.
They did. And they found that the acceptance rate for those additional, predicted tokens was between like 85% and
Yeah.
90%, which is amazing.
Wow.
So the model's making accurate predictions even when it's looking multiple steps ahead. And by incorporating this MTP technique into like a speculative decoding framework, they actually achieved a really significant speed boost.
Okay, so how much faster are we talking? Like, give me the
You
numbers.
saw a 1.8x increase in tokens per second.
Wow, that's huge.
Yeah. So DeepSeek-V3, it's not just more efficient during training, it's potentially much faster at actually generating text too.
That is a win-win. Okay, I am seeing why this DeepSeek V3 is like, everyone's talking about it. It's not just powerful, it's efficient, it's versatile, and it's open source. Like, it's really challenging how we think about AI. But before we, go too crazy praising it, are there any like limitations, anything we should be aware of? I mean, every like, groundbreaking invention has like its downsides too, right?
Right, yeah. No system is perfect, that's for sure. One of the biggest challenges with DeepSeek-V3, and honestly any large language model this big, is just the sheer amount of computational power that you need to run it.
Mm.
So, smaller teams or individuals, people with limited resources, they might have trouble using it effectively.
So it's like, having this like amazing sports car, but you need a racetrack to really see what it can do.
Yeah, that's a great analogy. And even with all the optimizations they've done, there's still room for improvement, especially when it comes to generation speed. That 1.8x boost from the MTP, it's impressive, don't get me wrong, but real-time applications, things like, chatbots, virtual assistants, they need those responses like lightning fast.
Yeah, yeah. So those instant replies we're all used to, that might take a little while longer with a model like DeepSeek V3, but I guess no AI is perfect, right? There's always going to be like more work to do.
Exactly, and that's what makes this field so, dynamic and exciting. The limitations of today are, tomorrow's breakthroughs.
That's a good point. Okay, so I want to go back to this whole idea of AI self-evaluation. It's amazing and also a little creepy, like we're really at the start of something big here.
It does feel that way, doesn't it? It's kind of like, watching a kid learn to ride a bike without training wheels for the first time. Like,
Yeah.
you're a little worried they're going to fall, but you're also just amazed, by how they're becoming more independent. And that's what we're seeing here. AI is taking those first steps towards self-improvement, and it's both exciting and, yeah, a little scary.
So what does this mean for like, the future of AI development? If AI can guide its own learning, does that mean like, human researchers are going to be less important?
I don't think it's about, humans being less important. It's more about redefining like what our role is. So imagine, right, a world where AI can help us, figure out what research to do, maybe suggest, I don't know, some new solutions, even help us understand these models better than we ever could on our own.
So it's like having an AI research partner, like, constantly pushing the boundaries and making us rethink things.
Exactly. And who knows, maybe someday AI will even like surprise us, come up with breakthroughs that we never even, thought possible. But as we, go further into this unknown territory, we need to be careful. We've got to make sure that human values and ethical considerations, those stay at the forefront.
Yeah, it's a balancing act for sure. Like balancing all this amazing potential with, the need for ethical guidelines and responsible development, all that.
Absolutely. That's why all these conversations that are happening about AI, alignment, transparency, accountability, they're so crucial. We need to have these conversations, set up clear guidelines, safeguards, all that to make sure that as AI keeps evolving, that it's actually benefiting humanity, as a whole.
So DeepSeek V3, it's more than just like a powerful language model. It's a glimpse into the future, a future where AI has, an even bigger impact on the world.
It really challenges us to think differently about, what's possible, to really embrace what AI can do, while also being aware of the ethical implications. It's a call to action, I think,
Yeah.
For everyone, researchers, developers, policymakers, everyone to really think about and have those conversations about the future that we want to create with AI.
This has been a really incredible deep dive, lots of insights, a few surprises along the way, and definitely some questions to think about, going forward. I'm still processing everything we learned about DeepSeek V3. I have a feeling that this is only the beginning of these conversations about, AI, its place in the world.
Yeah, I think you're right, and that's the beauty of it all, right? We're on this incredible journey of discovery, always learning, always adapting, always pushing those boundaries, of human ingenuity.
Well, to all our listeners, thank you for joining us for this deep dive into DeepSeek V3. We hope you learned something new, maybe had some of those aha moments. And until next time, keep exploring, keep asking questions, and keep the conversation going.